Hello friends, you're welcome to Enmatech Electrical. In this video we are going to do a complete coil rewinding of a 3-speed fan, a 3-speed induction motor. So the coil was damaged beyond adjustment, so we're going to do a complete coil rewinding of this coil. So I advise that you pay good attention and watch this video from start to the very end. So we went a step into explaining the whole circuitry of this fan coil, so that you will fully understand how it goes. This is the fan coil, so we need to uncouple it to see the inner view. Okay, this is the coil that was damaged. So if you look closely, you will see the area that got burnt, as you can see in the video. These are the various components. As you can see, the capacitor there, this is the switch, the speed control, this is the rotor of the induction motor and the casing. So this is the back casing, and you can see the bearing. That's the bearing. So these are the components. This is a closer view of the burnt coil. The first thing we need to do now is to strip this coil to remove the burnt windings. We are making use of our saw to cut out the bottom part of this coil. We do this, we will need a tiny spindle that can enter into those slots. So using the tiny spindle, we hit the windings out through the other direction. So once you do this, it can now be easy to remove these burnt damaged coil windings from the top parts of the lamination. So as you can see in the video. So now the bad coils has been removed. So it is advisable that you still keep them safe. Keep them safe. Don't discard them yet. I will let us know the need subsequently. Our number of slots is 16. Now the next thing is to remove the old insulation, because these insulation press pans may have been weakened by heat, the heat arising from the burning of the old coil windings. need to spend some fucking time and learn. So you observe and take down all necessary information about this particular lamination, so you can be able to reuse its parameters when you meet another lamination of the same values. Now we measure cuts and then replace the insulation press pan. So this is to avoid all form of electrical contact between the coil windings and the lamination core. Some are actually shorter because she dey get am ba. Olo, ìwọ̀n adé ò lè ń tẹ̀rẹ̀ lọ́nà. Mosquito are bullying you. need 16. Everybody. 16. This is the size of wire to use. This is copper wire number 38SWG. So I chose this because it's the same size of wire removed from the coil. That's the same size with the burnt windings removed from the coil. Now you pick one layer of the run windings, which is the outermost winding, in order to get the number of turns to be replaced. So you do the same to the start winding. So this is the reason I said the burnt winding shouldn't be discarded immediately. So using the number of turns gotten from the burnt coil, so I made these replacements. So as you can see, 4 for the run windings, which are the outermost windings, then 4 for the start windings, which are the innermost windings. So now let's take a look at the connection diagram or the winding diagram. Now pay good attention to this diagram. I'm going to explain it so that it doesn't be as confusing as it looks. So looking at this diagram, you can see a white colored circle. So this white colored circle is going to represent our lamination, like that the stator now, the stator core. So now we can see red curves and the blue curves. So the red curves represent the run windings, while the blue curves represent the start windings. So the points where this curve meet the white circle represents our slots. So if you count these points, they will give you 16, which represent the 16 slots gotten from our lamination or our core, our stator core. Now there are 4 windings or 4 coils for both the start and the run winding. So this number of coils are being represented in the diagram, as you can see, 1 2 3 4 with red color and 1 2 3 4 with blue color. Now I want us to bear in mind that each of these coils have 2 terminals, the starting terminal and the ending terminal. Now these terminals are what we're going to use to make the connection. For clarity's sake, we are going to call the starting terminal the left and the ending terminal the right. Now take a look at start coil 1 and run coil 2. Their lefts are joined together to give us our highest speed, speed 1, which has the blue colored wire. Now take a look at start coil 1 and start coil 4. Their rights are joined to form the middle speed. The middle speed is represented with the white cable. Now take a look at start coil 2 and start coil 3. Their right terminals give us speed 3. Speed 3 is the lowest speed, which is represented using the red wire. Look at run coil 1. Run coil 1. The left of run coil 1 gives us the yellow wire, which is one terminal of the capacitor. Lastly, take a look at start coil 2. The left of start coil 2 gives us the second terminal for the capacitor. So it is the black wire on our fan, but it's represented with pink wire on the diagram because the background of the diagram is black. Now the remaining terminals are looped right to right, left to left. I don't know. When you see the man use paint, Onishi de male use paint hanish.
Oh, and they don't use paint now. Public toilet, so they should.
The first coil of the run windings has been successfully slotted. Then the left and right terminals will be tested for continuity using our multimeter. This will be done for all the other coils, both start and run. Now we create an insulation between the starts and the run windings, after which we brace with a bracing rope, but not too firmly in order not to harm the coil windings. These are some of the interesting contents of our YouTube channel. Please do go through them. They are quite interesting, educative and informative. So kindly click your subscribe button if you have not, and comment on the comment section in case you meet any confusion or you have questions to ask. Also remember to share these videos with your friends. Welcome back. Now we are going into the connection proper, but first of all, let us identify the right and left terminals of each of the coil sets. So basically, this is our fan coil. We are done. So the next thing to do here is to apply our varnish, then uncouple. So but before we do that, I want to explain to us basically like a kind of rough diagram of what we just did. So this is a typical connection of an induction motor. So this to be our start winding, this as a run winding, and this is the common. So if you notice from what we did here, most of these taps, these speed levels were made from the start connection. So it's something like this. After some turns, you get the first speed 1. After some turns, you get speed 2. After some turns, you get speed 3. So we all know that resistance increases with length. So as we move on, this is a lesser resistance, higher resistance, and the highest resistance. So this is inversely proportional to the speed. So what this means is that this one with a lesser resistance, this is our speed 1, we have a higher speed. So as the resistance is increasing, the speed will be coming down. This is the middle speed, and this is the least speed. So we are going to see that now on our meter, using our meter. So this is a better illustration of the explanation given in the previous screen. We set this meter to a 0 resistance, so it's at 20k now. So as you can see, it's at 0 now. This is our start winding. This is our speed 1, 0.6. So this resistance should be less than these other two speeds. This is our black, is a common too for capacitor. So this is speed 2 and this is the least speed. So the resistance now should be increasing. So you have checked speed 1 gave us 0.6. So speed 2 should give us something higher, 0.7. This is resistance. And the least speed should give us a higher resistance, 0.85. So that is it. So the lesser the resistance, the more current that will flow. That's the higher the speed. As we all know, resistance is opposition to flow of current. So there will be more current flow in the higher speed because we have a lesser resistance. Then the middle speed is this speed 2, 0.7. And the least speed, we have the highest resistance, 0.8. So this is the highest speed. This is our speed 1. This is the middle speed, our speed 2, and this is the least speed, speed 3. Come back again, speed 2, then highest speed, speed 1.
Please kindly click the subscribe button and bell to stay updated with trending videos, and don't forget to like, share.